Hi there, and welcome to the channel. Today we are going to talk about how to build a package with Swift. Now, in today's episode, we'll cover how to get set up with Swift packages. We'll cover how to add your code. We'll cover how to distribute it locally so you can import it into your native projects or wherever you are using Swift and Xcode. We'll cover how to distribute the package to SPM and how you can pull it in through a central repository. And along the way, we'll take a look at some of the gotchas that I had to deal with when I was building my first package. So without further ado, let's go ahead and get started. Okay, so first we want to go ahead and open up Xcode. Now, if you don't have Xcode, you can go and find that in the App Store and download it for free. And it might take some time to set up, but once you have it, you'll be good to go. So if you haven't got it, just pause the video and install it. Otherwise, you can open up Xcode and we should be ready to get set up. Now, what you want to do when you open Xcode is you want to go to File, New Project, and you should see the screen right in front of you here. Now, we are going to go ahead and choose Swift Package down in Framework and Libraries, and we'll hit Next. And now we need to create a name for our library, and I'm just going to call it this Unleash Client Swift. And I'll go ahead and say Unleash Client Swift like that. And that's going to go ahead and set up some basic files for us. And we'll go ahead and take a look at what they mean in a second. So you can see right here on the left-hand side in Xcode, we have the package name here at the top. And then we have the contents. We have a README file. We have something called package.swift, which is what you see here. And then we have the sources directory, whereas that's the place we'll put our actual source code. And then we have tests. So let's go ahead and just take a quick look at package.swift before we start adding our code. Now, in package.swift, we have the products, which basically just defines the executables and libraries that a package produces and makes sure that your package is importable and visible. We have an empty dependencies section, which we'll fill out because we're actually going to use a dependency here, but this section is used to pull in other packages that your package might depend on and declare those in the package description so that once your package is imported into another project, they will know that, okay, you need this package as well. We'll go ahead and fetch that for you. And we'll see that later on as well. Now, the targets section, they're it says, the basic building blocks of the package. And you can have targets that depend on other targets. And you see we have two right here. It's basically our Unleash client and our test target, which are defined here on the left-hand side. So what we'll do is we'll go ahead and get started adding some code. Now, I have some code prepared, and I want to go ahead and import that into this project. And then we're not going to spend a lot of time looking at the actual code because that's not what this video is about, but we'll go through it briefly and then we'll get started on actually distributing this package. So I'm going to go ahead and open up this file here, or this folder, and I'll add a new file. I'm going to call this folder.swift, and I'm going to add in some code here. This is going to be our Polar class. And we have an error here. We'll handle that in just a second, but we'll go ahead and add another file here first. And this is going to be the utils. So we'll have a little util function here. That's just going to help us a little bit with some operations that we want to perform. And then the meat of the package here is going to be the proxy client or the Unleash client. So just briefly, I work at a company called Unleash, and we do feature management. And recently I had to build this Swift SDK. And all it does is talk to a proxy that we have, and we receive a feature toggle configuration in return. So that's what this is going to be doing. And we'll take a look at the code in a second. And as I said, we won't focus on it a lot. We'll just briefly take a look at it in case you're curious of what it does. So you see here we have an import, Swift event bus, and we have foundation, which we also are going to need. And Swift event bus is actually a package that we are depending on. So I need to go ahead and declare that in my package.swift. Otherwise, it's not going to know how to find that module. So what I want to do is I'm going to go to the dependencies section, and I'm going to say .package, and we're going to provide a URL, and I have the URL, and I'm going to paste that in here. That's going to be the URL, and we'll say from, and that's the version number, and it's going to be 5.0, 5.1.0. All right. And that should be it. Now you can see automatically on the left-hand side, Xcode is fetching this dependency, and it now knows that my package needs this to function. So it went to the repository and fetched the code. Now, I haven't declared that my target actually needs this dependency, because that happens down here. So what I also need to do is I need to make sure that I put Swift event bus here. And let's go ahead and see what happens if we don't do that. Just remove this. And now inside of our code, if we go ahead and try and build, we get a problem. And the compiler will tell us that there is no such module, Swift event bus. And I can't tell you how frustrating this was to experience the first time I was working with this. No such module errors were popping up left and right, and there's not a lot of documentation around it and not a lot of issues on it, so I thought it was maybe just a really obvious issue. And in the end, I suppose it was, but it wasn't as obvious for me some of the issues that cropped up with no such module errors. This one is pretty straightforward and easy. Obviously, we need to declare in our package.swift our target dependencies. So if we just go ahead and put Swift event bus in our dependencies and we try and rebuild, and now everything should work fine, and it doesn't because yeah, that's right as well. So now it's telling us that we are using a feature that's only available in macOS 10.12 or higher. So that's quite interesting. That means that we need to declare in our code that this is only available for macOS 10.5 or higher. So I actually have 10.15 because I'm using another feature that requires 10.15, but go ahead and put this in here. And that should take care of the error. And if we rebuild, now it should be happy, but there is another error. So let's go ahead and see. Yeah, so the test is not happy, and I can understand that. So what we'll do for now is we'll go ahead and just remove the test targets, and building that should go ahead and give us the green light. All right, so now we've set up our package, we've added our code. Let's just briefly take a look at what's here. So the code has, first of all, a few structures defined. These structures represent the data that we want to fetch from an API. So I'm expecting a feature response here. And the feature response is going to have a list of toggles. So I'm going to go ahead and show you how this is going to look. I'm just going to copy and paste in the JSON response here and close the bracket there. So the JSON response looks like this. So it corresponds to the feature response here. And it has a list of toggles. And a toggle is what is between these brackets right here. That's one toggle. And this is another toggle. And this is the third toggle. So if we scroll down a little bit to the toggle struct, you can see that we have a name, which is a string, a enabled property, which is a Boolean, and we have a variant, which is in itself a variant struct, which has these properties. So we're just defining out what we are expecting from the API. Now, also note this, and this is quite important, the codable, I would say protocol, or I don't remember exactly what it is, but it's a type or protocol that we are saying that our feature response and our structures adhere to. So we're basically just telling Swift that these structures are both encodable and decodable. And that's important because otherwise we wouldn't be able to decode the JSON into these structures. So we're getting JSON back, and what we're doing is we're transforming that into a data structure that Swift can understand. So basically, we are decoding the JSON into an understandable Swift data structure. And that's why we need this codable interface here. And you can see I have that on almost everything that's coming from the API. And that's because we can't only have the feature response codable, we need to have everything inside of the feature response type needs to be codable as well. And you could do decodable, but codable is just a shortcut to say decodable and encodable. So there you have it. Now the code basically just inits a instance of this client, and all it does is start a poller. The poller goes to the API and asks for data on a given interval, and you can start and stop it. And then you have a few methods to check against the local cache. So what we do is we take the data, we put it in a map, and we keep that map in the local cache so we can ask against it using this method. And then we are using the Swift event bus, the package that we pulled in. We're using that as a subscription pub sub service where you can subscribe to events, and you can define callbacks that you want to run when those events are emitted. Now, we're going to take a brief look at the poller as well. The poller is responsible for fetching the data. It starts a timer. When the start function is called, the timer runs for 15 seconds, every 15 seconds, or on the refresh interval, if that's given. And basically, we are just fetching the data here through a data task, and we are decoding the JSON response here into the feature response structure that we just saw. Okay, so I don't want to get too far into the weeds of the code here. It's not that much. We've been through what it does, so we'll move on and talk about how to distribute this package. All right, so we have our package, we have our code, we're good to go. We just want to start using this both locally and then distribute it to a central repository. So let's go ahead and see how we can do that. And first, what we want to do is we want to open our terminal or iTerm or whatever you use, and you want to navigate to where you have your package code. So basically, what we want to do is we want to commit our changes. And this is really important, and I'm going to explain why in a second. But inside of a repository or inside of our folder, we'll have a Git repository already set up for us. Or if you don't have that, you can set one up with Git init. But in this case, we have one already set up. You can see we have the main branch here. And what we'll do is we'll go ahead and say git add, and then we'll say git commit, and we'll give it a feed add files message. So that'll just add all of our files that we added. And now what we want to do is we want to create a new project here. So we'll create a new project and we'll import our package into that project and start using it. So we'll create an iOS app and we'll call that YouTube Swift. And we'll create that inside of a directory on our computer. And that's going to take a little bit of time. And while that's creating, it's already good. So let's just go ahead and continue. What we want to do is we want to go to Swift packages and we want to go to add package dependency. Now it's going to ask us to enter a package repository URL. But what we want to do now first is we want to provide the local package that we have on our machine. So inside of our package directory, let's go ahead and write pwd, and that's going to give us the working directory. And inside of here, we'll do file : / make sure it's only 3, and then we'll provide the rest of that path. So here now, what we want to do is we want to add the branch that we want to pull from, and that's going to be the main branch. And this is why it's important that we have committed all of our changes, because unless they are committed, when we are pulling in our package, the changes that aren't committed are not going to be propagated to our project. And that's because we are pulling from this branch, and the changes need to be committed to the branch in order to be pulled in and available. So that's why it's important that every time that we want to propagate changes in our package, we commit those changes on the branch that we're pulling from. Now, we'll see another way of doing this later, but for now, let's just go ahead and import the package. So you can see it's resolving this now. And you can see it's also finding the Swift Event Bus package. And on the left-hand side here, in a minute, you'll see the Unleash client's Swift, and it's pulling from the main branch. And you can see the Swift Event Bus with package version 5.1.0. All right. So now we have our package. Let's see what happens if we try to import the package in one of our files. So we'll do Unleash client Swift. And lo and behold, no such module found. And I've got to tell you, this is one of the most frustrating error messages I've found in my entire life. I spent a lot of time trying to figure out why I couldn't import this module when everything was according to the documentation and according to what everyone else was saying on issues on Stack Overflow, that this was supposed to work, and yet it didn't work. And the reason why it didn't work is because in my package, I'm using functionality that has restrictions on it. And since it has restrictions on it, as far as I can tell, I need to add, or we need to add, a platforms array inside of our package. And the platforms array is going to define which version you need to have of the different operating systems in order for this package to work. So if we add that and we rebuild that, and the build failed, so let's see what that's all about. Right. So somehow I managed to add back my test target, so I'll just remove that and hit rebuild. And now it's succeeded, and we need to go to our terminal, and we'll do git add everything, and that's going to be our package.swift, and we'll see fix, add platform targets, or platform definitions. And let's head over to our test application. And now what we want to do is we want to go to Swift packages, and we want to say update to the latest package version. And since we committed that change, this is going to propagate, we'll fetch the new package, and now if we try to build, it's going to recognize that we have the package, we're trying to import it, and the build is going to succeed. Hopefully. And it does, and that means that this error will go away shortly. And there we go. And now we can do var unleash equals unleash client Swift, and we get autocomplete. And now we can use any of the public things or structures and classes that we've defined. So we can say we want the new unleash client, and that's going to take some arguments, and we get the autocomplete here, and we can go on and on, but now we finished our mission, which was to import this package and use it in this project. And right now it's a package that exists locally on our machine, and we're importing it with a local file path. So the next thing we want to do is to actually get this on a central repository. And luckily, it's really easy. So let's go ahead and do that now. So the way that Swift Package Manager works is it actually utilizes GitHub and GitHub tags, or Git, I should say, and GitHub tags. You could have your Git repository on any repository provider, but I'm going to put mine on GitHub. So what I'll do is I'm going to navigate to GitHub, and I'll create a new repository. And I'll call that unleash client Swift. If I can spell that right. I'll make it a public repository. And I'll go ahead and grab this and head back to my terminal. I'll add the remote, and it seems like I've already done that because I've tried this once before. No shame in doing it twice. And then what I want to do is I want to push this up. All right, so if I refresh now, my code should be available here. And it is. And the next thing I want to do is I want to create a sem-versioned tag for this package. So I'll go ahead and say git tag, and it's going to be an annotated tag. So I'll give it version 1.1.0 1.0.0, and I'll just put this message as the message, and we already have that tag, which is convenient for us, but that's how you would use it, or how you would create a new tag. So let's go ahead and just create version 1.1.0. And then we'll go ahead and push and origin, and we'll say follow tags. And that's going to push our tags up to our GitHub repository. Now, if we refresh, we should have one tag, and that's 1.1.0. Okay, so now that we have our tag and our code in the GitHub repository, let's go ahead and use that to import our package. So we'll go to the YouTube Swift app. Excuse me. We'll remove the package dependency here, because that was our local version. And what we'll do is we'll go and copy this link without the releases part. And we'll repeat the process from before. Go to File, Swift Packages, add package dependency. And we'll paste in the link. And it automatically went and found it for us. And now we want to use the version rule, which says that we want to pull in everything up to the next major. So what that means is that we're defining a set of rules for this package. And we're saying that whenever this package changes a minor version or a patch version, we can go ahead and use that package. But as soon as we are bumping the major version, we don't want to upgrade anymore. And that's because a major version usually involves breaking changes. And so you want to have that as a conscious choice, so that your code doesn't break accidentally when you update. So in this case, we are fetching version 1.1.0, and we don't want to fetch above 2.0, or we don't want to fetch 2.0 at all. We want to fetch everything up until 2.00. All right, so now we're pulling this in, and that's successful. And we again have the Swift event bus dependency because our package depends on that. But now we have our Unleash client version 1.1.0. And everything should still work as intended. So we're still able to import our Unleash client. We're still able to use anything in the package. And the only difference is now that we actually have it on a central repository, and anyone else can use our package as well, which is amazing. Now, there were some gotchas along the way here. The no such module error with the platform dependencies was a real tough nut to crack, to be honest. Not a lot of documentation, and you know that feeling you have when you feel like the whole world is just not having a problem that you're having, and you're either really stupid or no one's had that problem before. That's what I felt. I think I was just thrown off a little bit by the error messages. Probably could be improved, to be honest. But we managed to solve it, and hopefully you found this useful too. And if you got something out of it, please leave a like and subscribe with notifications on. If you didn't like it, leave a dislike and perhaps a comment on what I can improve. Either way, I think we're at the end of this video, and I would like to thank you for sticking along, and it's been a pleasure. I'll see you in the next one.